All right, so I mentioned the other day that there's two different ways we've learned for expanding out different expressions. One way is our good friend, the binomial theorem, and another way is our good friend Maclaurin series. And I mentioned that these have to be equivalent because they're two different legitimate ways of expanding out an expression. So I wanted to show you that, and that's right, you aren't working. And I'd also like to apologize in advance for my screenwriting tools are being real annoying. Okay, so 1 plus x to the nth power. So what the binomial theorem says is that if you imagine a bunch of copies of that, if you imagine the factors written out all in a row, n copies of them, that there are different numbers of ways of getting each of the terms in the expansion. So first thing I'm going to do is start writing out the binomial theorem. If I want to get the number 1, that means that I had all of the ones multiplied together and I had none of the x's multiplied together. That's the only way to get the number 1. And what that meant is that I chose n copies of 1 and I chose 0 copies of x. So there's two different ways you could write that coefficient. You could either write n choose n, if you're thinking about how you chose all n of the ones, or you can think about that as n choose 0 for how you chose all 0 of the x's. Either way is totally fine. I think I like the n choose 0 version more. Not that it matters. Okay, the next term. Think about how you can get x. That means that you multiplied n minus 1 copies of the 1, and you multiplied a single x. Well, how many ways are there to do that? Well, there's n factors written out all in a row. So there's n factors, and you chose one of them to be the x. Alternatively, you could say n choose n minus 1 because you chose n minus 1 copies of 1. This goes in general, dot, dot, dot. You can write out the general term, 1 to the n minus k, x to the k, n choose k. Means you chose k copies of x, and you chose the rest of them as ones. And then the very last term, so we'll have another dot, dot, dot. The very last term would be, I guess, sort of the opposite of the first term. 1 to the 0, x to the n choose n. So that's the good friend, the binomial theorem. Maclaurin series was another way of expanding things out. And we talked about how it was an approximation when you have like an exponential function or a sine function, because obviously a polynomial is not going to be exactly the same as a trig function or an exponential. But 1 plus x to the n is just a polynomial. So the Maclaurin series should be exactly the same as the polynomial itself. So what do? We start taking derivatives. We start plugging in 0 to those derivatives. We set up the Maclaurin series. So I'm going to switch colors just to show you that I'm doing something different here. Let's choose this color. This looks cool. Okay, so if we have the original function, then we get 1 plus x to the n. The derivative, you multiply the n in front. The second derivative, you multiply the n minus 1 in front. And that's an n minus 2. I knew my screenwriting was going to stop working. The third derivative, you multiply the n minus 2 in front. Oops, n minus 1 from before, n minus 2, 1 plus x to the n minus 3, etc. The k derivative, you're going to have everything up until n minus k. And so the way you can write that is you have n factorial over, let's get this out of the way, n minus k factorial times 1 plus x to the n minus k. So notice that the power matches with the order of the derivative, and the coefficient goes to 1 less than that. So the second derivative goes to n minus 1, the third derivative goes to n minus 2, the kth derivative goes up till right before n minus k. So that's why I'm canceling out n minus k factorial on the bottom. Remember, the next thing that we do is we plug in 0 to all of these. So we get 1, n times n minus 1, we plug it in 0, n minus 1, n minus 2, here n factorial over n minus k factorial. Now, Maclaurin series says those are your coefficients. So our function should be 1 plus n times x plus n times n minus 1 x squared over 2 factorial plus dot dot dot. Here we have n factorial over n minus k factorial x to the k over k factorial all the way up to n factorial over n factorial, or sorry, n factorial over n minus n, which is 0 factorial, x to the n over n factorial. So if you simplify that, what you'll notice is that this right here is how many ways you can choose 1. This is n choose 1 right here. Let's write it in a different color on top of it. So this is the big reveal that we were building up to. This first term is really just n choose 1. The second term is really just wait a second, n choose 2. This third term, if we gather all of this, you'll notice is just n choose k. And this last term right here is just n choose n. So all of the binomial coefficients match up with the Maclaurin series coefficients. And so I think that's just kind of a neat connection between some stuff we learned in Unit 1 and stuff we learned in Unit 8. So ask questions. Let me know what I can do to help out. Thank you for watching.